Number 19, three graphs labeled 1, 2, and 3 are shown above. One is the graph of f, one is the graph of f prime, and one is the graph of f double prime. Which of the following correctly identifies each of the three graphs? Well, we have to kind of take a guess on which one we think we should start with. I personally thought that 3 was f because it's doing the most moving around where the others aren't doing quite as much moving around. So I usually try to pick the most difficult one for my f. So if I did that, if I let number 3 be my f, then I'm going to do an f prime chart based on it and an f double prime chart based on it. So I need to figure out where are the slopes going positive and where are the slopes negative. So I notice that this function is going down all the way till I get to 0. So f prime would be negative, and then it would be positive after that because the slopes, then it starts going up. Right, so if I just basically look at my f, well, I'll do that in a second. And then concavity, so if I'm looking at f, I'm going to be looking at the concavity. I notice that it's concave up right about till I get to here, and I'm just going to call that A just so I have a value to refer to. So it's concave up until then, and then it's concave down all the way till about, I'm going to say about right here, and I'm going to call that B. Then it's concave down, and then notice it changes to concave up again. All right, so if I'm looking at the graphs, I need to figure out if whichever one is f prime, it's going to be below the x-axis till 0, and then above the x-axis after 0. So if you look at choice 2 is below the x-axis even though it hits the x-axis, but it stays below the x-axis pretty much till it gets to 0, and then it goes above. So 2 has to be my f prime. And then my f double prime, if I'm looking for f double prime, again, my f double prime is going to be above the x-axis until A, and then below the x-axis between A and B, and then above the x-axis after B, which definitely meets the criteria for number 1, because number 1, notice it's above and then below and then back above. So we have found it. So my choice will be E. All right, number 20. A particle moves along the x-axis so that any time t is greater than or equal to 0, its velocity is given by that velocity formula. The total distance traveled by the particle from t equals 0 to t equals 2 is what? So total distance traveled, we know, is the integral from 0 to 2 of the absolute value of velocity. And then all we need to do is just use that velocity formula right in that formula. It's pretty straightforward. When I do that, I get 1.540, which is choice C. All right, number 21. If the function f is defined by f of x is equal to the square root of x cubed plus 2, and g is an antiderivative or an integral of f, such that g of 3 equals 5, then g of 1 is equal to. So they're telling me something about the integral, that g is an integral of f. So I'm going to take the integral of f, and when I do that, I know I'm going to end up getting g. Okay, so I'm going to put some limits on here. So if I do and I notice that we're given an x value of 1 and an x value of 3, so I'm going to put 1 and 3 on there. And so I know if I take the integral of 1 to 3 of f of x, I'm going to get g, but notice I do have to evaluate g at my endpoint. So this is going to equal g of 3 minus g of 1. And now what we're going to be doing is just using our calculators here. For this problem right here, we know what f of x is. It is equal to the square root of x cubed plus 2. And then we still have g of 3. Actually, they told me it was 5. And then we don't know g of 1. So on the left side here, I can use Math 9 to figure that out. And when I do that, I'm going to get 6.585. And then I still have equals 5 minus g of 1. Well, I can just figure this out now just using algebra. This will give me 1.585 is equal to negative g of 1, and then if I multiply both sides by negative 1, I'll get g of 1 is equal to negative 1.585, which is option B. All right, 22. Let g be the function given by g of x is equal to the integral from 1 to x of that function. Which of the following statements about g must be true? So I do notice they're just giving me some different things, so I'm just going to look at both of them. If this says g is increasing on 1 to 2, which means what we're going to be doing, the first one, it says g is increasing on 1 to 2, which means from 1 to 2, that g prime would be positive, which means if I picked any number between 1 and 2 and found g prime of that I should get a positive answer. So I'm actually going to pick g 1.5, which means if I were to find g of 1.5, I should get a positive number for that statement to be true. So since I know that g is equal to the integral, g prime is going to equal just what's inside here. So g prime of 1.5 will just be 100 times 1.5 squared minus 3 times 1.5 plus 2 times e to the negative 1.5 squared. And if I figure that out, it will be negative 2.635. This says I should get a positive value, and I got a negative value, so that statement is not true. Okay, this next one says g is increasing on 2 to 3, which would mean g prime between 2 and 3 should be positive, which means if I pick a value somewhere between 2 and 3, I'm going to pick 2.5 and find g prime, it should give me a positive answer. So we're going to try this again. So again, the derivative of the integral is just a function, so I'm going to get 100, 2.5 squared minus 3 times 2.5 plus 2 times e to the negative 2.5 squared, and when I figure that out, I get 0.145, and so it is true, I got a positive value, so g is increasing on that interval. And then the last one, it says g of 3 is greater than 0, so I can pretty much just plug 3 into that equation for x, so I'm going to get the integral from 1 to 3 of 100 t squared minus 3t plus 2 times e to the negative t squared dt, and I can use Math 9 to help me figure that out, and when I use Math 9 to figure that out, that gives me negative 1.942, and it says that g of 3 is greater than 0. Well, that definitely is not a number that's greater than 0, so 2 was the only one that worked, which is choice B. Number 23, for series S, let S equal 1 minus 1/9 plus 1/2 minus 1/25 plus 1/4 minus 1/49 plus 1/8 minus 1/81 plus 1/16 minus 1/21 plus a sub n. And then it says a sub n is equal to 1 over 2 to the n minus 1 over 2 if n is odd, and it is equal to negative 1 over n plus 1 squared if n is even. And it says which of the following statements are true, and it's talking about convergence or divergence. And for part 1, it says S converges because the terms of S alternate, and the limit as n approaches infinity of a sub n is equal to 0. Okay, I'm automatically going to shut that one off because if we're testing for convergence of an alternating series, we do have to do 3 tests. We have to test not just the limit, but we also have to test to make sure all the terms are positive, and then we also have to make sure that the first derivative is negative or the terms are decreasing. So 1 is just not an option. All right, number 2 says S diverges because it is not true that the terms of the sequence are decreasing. That's basically what this is saying. And if I looked at that, the absolute values of them, my first gut instinct I circled to, because the terms of the sequence definitely are not decreasing, because I have 1/9 and then I have 1/2 and then 1/25 and then 1/4, because they keep going back and forth. So I probably would have chosen choice 2. However, that is not the one. It's actually going to be choice 3, and let me just show you why. Because of this one, because I actually have 2 different things going on with this problem. I don't just have one formula that fits it all. There are 2 different formulas. What I decided to do on this one is figure out the convergence of each one of these, and then decide if they both converge. Then if you add 2 convergent series together, you definitely get a convergent series. And if one of them diverged, then obviously you'd get a divergent series. So that's the approach that I took on this one. So if I took the first one with a sub n was equal to 1 over 2 to the n minus 1 over 2. Okay, the first thing that I did with this was the divided by 2. I knew that this whole sequence is actually being square rooted. Okay, and then the second thing that I did was I separated out I made this 1 to the 2n and 2 to the negative 1. And then from there, because we're just adding our exponents when we separate them, the next thing that I did was I kept my square root still. And then since this was 2 to the negative 1, I brought it up top to make it positive. Okay, and then I noticed that inside I almost have a geometric series. If I rewrite it correctly, this is going to be 2 times 1/2 to the n. And so since I wrote it like this, I do notice that what's inside of the square root, we can actually deal with the what's inside first and then square root it. So if I'm looking at this, this is definitely a geometric series. And since r equals 1/2 and that is less than 1, this series would converge. So far the first series converges. So now we're going to check the second series. The second series was a sub n equals -1 over n plus 1 squared. Okay, we could do an nth term test, which gets us nowhere. We could do the ratio test, which actually the limit would equal 1, which is inconclusive. So I noticed on this one I'd like to use the integral test to test for convergence. So I'm going to take the integral. Actually, remember we have to take the limit as w approaches infinity of my integral. Since we're starting with n being even, I started with 2, and then I went to w, and then we'll have -1 over n plus 1 squared. I bumped my negative out front. And then I let u equal n plus 1. du is equal to 1, which is right there. So when I rewrite this, this is going to be negative the integral of 2 to w, and this would be u to the -2 du. So when I take the integral of that, I'd get -1 u to the -1. But there's already a negative out there. So that turned to positive, so that just turned it into 1 over u, which is 1 over n plus 1. And now I get to evaluate it at w and 2. And when I plug in w, I get 1 over w plus 1, minus when I plug in 2, I get 1/3. And then remember this whole thing, we were finding the limit as w approaches infinity. So if I let w approach infinity, if I put infinity in here, I end up getting 0, and then minus 1/3, so I get -1/3. So since I actually got a finite limit, then I know that this series also converges. So since both of those separate series converge, if I separated it into two separate series, a convergent series plus a convergent series would also converge. So it is choice 3. Number 24, let g be the function given by g of t is equal to 100 plus 20 sine of pi t over 2 plus 10 cosine pi t over 6 for between 0 and 8 for t. G is decreasing most rapidly when t equals what? So if g is decreasing, I know I'm going to consider g prime. And if it's decreasing most rapidly, I would expect to have the largest negative number for my derivative. And you might think about this a different way, but that's the way that I thought about it. So what I'm going to do is actually use my choices, and so if it's decreasing most rapidly at 0.949, that would mean that g prime at 0.949 would give me the largest negative number. So I'm just going to actually, for each of these, I'm going to be calculating them. G prime 5.965, and then g prime of 8.000. All right, so what I'm going to do from here, since I'm just calculating a derivative and I get to use my calculator, I will be using Math 8 for every single one of these. So when I do that, g of 0.949 gives me 0.018, and g prime of 2.017 gives me -35.962. G prime of 3.106 gives me -0.021. G prime of 5.965 gives me -31.464, and G prime of 8 gives me 35.950. So when it asks me for g is decreasing most rapidly when, I said we are going to be looking for the largest negative number for my derivative. The largest negative number occurred right here. So g is decreasing most rapidly when t equals 2.017.